chapter 5 on the 1324. We're going to cover simple interest, compound interest, and annuities, future and present annuities. Okay, so again, these are the topics that I'm going to cover. So let's begin with simple interest. Okay, guys, this is a formula for simple interest, INT. But I believe in the book it says I instead of INT. I put INT for interest, but it's the same formula if you put an I or an INT. But anyway, guys, this is a formula for simple interest. So there's four, variables that you have to extract the information and put it there, right? Except for one. Everything will be given except for one variable. So the interest is a fee paid to use someone else's money. The PV is the present value or the principal. The R is the interest rate, and the T is time in years. Okay, now there's also another formula that you use. Okay, if we use a formula, guys, right? For example, the interest is equal to present value times R times T. Then to find the future value is equal to PV plus INT. From this formula, we're going to come up with another formula that is also simple interest formula. For example, how do we derive to our next formula? Right? The INT or the interest is equal to the PV RT, right? So I'm going to plug that in there. Now, what do these two on the right side, what do they have in common? They have in common the present value, so I'm going to factor it out. What's left? 1 plus RT. So this is my other formula, guys, for simple interest. Right? Is this one on the left, and also this one on the right. Those two formulas are used for the same purposes. Okay, let's do some examples. Right? And I need to tell you what everything stands for. Same thing as the one on the left. So this is what you need to know. Okay, if months are given, and then the time will be given months over 12. Say it was weeks, right? If say it was like in 18 weeks, so then you divide 18 by 52 because everything has to be in years. But most of the times it's going to be given in years or it's going to be given in months. Okay, so this is good to know. Also, one more thing, the interest rate must be in decimal, right? So, example, 5% is equivalent to 0.05. Okay. Okay, now here's the first example. Martha borrowed $12,000 from her uncle to buy a used car. Her uncle charged simple interest at 3.5% for 5 years. Find the total amount that Martha paid to her uncle and how much interest did Martha pay. So which formula should we use? Should we use the interest formula, which is interest equal to present value, R times T, or should we use the future value of the simple interest? Does it matter? No, it doesn't. Okay, I'm going to do this one in two ways. First, I'm going to use the formula here on the left, and then I'm going to use the formula on the right, just so you know that you're going to get the same thing. Okay, here we go. So let's first start with the interest formula, which is interest is equal to present value, interest rate times the time. Okay, now if we use this formula on the left, then these two formulas go together, because to find the future value will be the present value plus the interest. Okay, again, these two formulas go together. So now, and this is I tell my students that I want their work done, right? Because I'll give them credit if you know how to extract the information from the word problem. So it says Martha borrowed $12,000 from her uncle to buy a used car. Her uncle charged simple interest at 3.5% for 5 years. Find the total amount that Martha paid to her uncle. So here, guys, really, we're looking for the future value, right? But we can use this formula also to find it. So then, right, so my present value is 1,200. Everything in green, guys, is a main information from this word problem. My interest rate is 3.5%. But we need to convert it to a decimal. So it's going to be 0.035, right? You move the decimal place 2 places to the left, and you drop the symbol. Or you can divide 3.5% by 100, right? And it'll give you a 0.035, and you drop the symbol. Either way will work. The time is already in years, right? So it's 5, so it's going to be 5. So all we do is plug everything in the formula, right? There's my present value, which is 12,000. There's my interest rate, which will be 0.035. And my time is in years, so it's 5. And all you do is use your calculator, guys, to get the result. So it's going to give you 2,100. That's how much money was in interest. Now, but the question is, find the total amount that Martha paid to her uncle. What we just got, the 2,100, is the answer for the second part. Okay, so to find the future value, then we use the other formula, which is future value equals to present value plus the interest. So that's my future value. My present value was 12,000, and the interest was, or is, 2,100. We add them up. That's going to give us 14,100. So to answer the questions, the first question, total Martha paid was 14,100. Right? That's how much she paid. How much money did she pay in interest? Was 2,100. Now I'm going to do this very same problem, but we're going to use the other formula. Okay? Remember, we got 14,100 and we got 2,100. We're going to get the same results using the other formula. Again, same scenario, but different formula. So with this formula, guys, we're going to find the future value, right? How much? I mean, the total amount that Martha paid to her uncle. But if we use this formula, then we have to use this other formula that goes with it. It's going to be the FV equals to the interest will be the future value minus the present value, which I show you right now. Anyway, again, it's the same interest rate, same time. Let's plug into the formula. So if we use this one, right, it's going to be the present value is 1,200. I mean 12,000. 1 plus 0.035 times 5. Right? Put that in the calculator. It's going to give you the 14,100. Now, this is the formula that I was talking about. So to find the interest, it's going to be the future value minus the present value, which will give us 14,100 minus 12,000. The result is 2,100. You see, guys, we get the same thing on both ways to work out this problem with both different formulas. Okay, those two formulas are called the simple interest formulas. Okay, now let's do another example here. It says Mariana will need to pay a tuition bill of $7,500 for her daughter in 10 months. What dollar amount can she deposit today at 1.25 simple interest to have enough money, to pay for the tuition bill? Okay, here's my scenario. So again, we're going to use, right, this formula has to be, for this one, there's no option. Because here, guys, they give us the future value, right? This is what Mariana needs to pay in the future, right? In 10 months, she needs to come out with 7,500. So then, right, what are we looking for? We're looking for the present value. How much money must she deposit today? So the future value is 7,500. My interest rate is 1.25%. Compared to a decimal will give us 0.0125. The time, guys, is 10 months, right? Remember where I said at the beginning that be careful, guys, because the time has to be in years. Here's a common mistake that students make is that they just put 10 there, which is not correct. You have to put 10 over 12 because everything has to be in years. Since there's 12 months in a year, we put 10 divided by 12. Now, all we do is plug everything into the formula. Right? The book likes to use this formula here. Okay, but I'm going to show you how to use this very same formula with one steady flow. Okay, but first, let's do it the way the book does it. So this is a formula, guys, for present value. Okay, so it'll be 7,500 divided by 1 plus 0.0125 times 10 over 12. Hey guys, this formula, guys, I don't really like because a lot of students make the mistakes because to put into the calculator how it is, you have to know how to put the parentheses. And a lot of students, they don't know how to do that. That's why I'm going to show you another way to get the answer that's very student-friendly with the calculator. Okay, but since my math lab shows you this way, I have to show you this way too first, and then I'll show you the other way. So we have 7,500 divided by 1.010 for 16667. It's going to give us $7,422.68. So that's the answer, right? That's a payment. That's how much money she has to pay right now. Okay. Here's another way that's easier without leaving your calculator. Okay, using a TI-83 or TI-84 calculator. Here's how we're going to do it. Okay, I'm going to enter just the way it is right here. Okay, I'm going to enter parentheses 1 plus 0.0125 times 10 divided by 12. If you do that in your calculator, guys, this is the result. Now you're going to hit the inverse key. The inverse key is like multiplying by the inverse on both sides. So you're going to hit the inverse key. I believe in your calculator, guys, let me take out my calculator real quick. The inverse key, if you cannot find it, is on the first column, on the first column, fourth row. Okay? It's where it says second, you go all the way down, and it's the inverse key is the first column, fourth row. So you're going to hit that key, right? And then you should see answer to a -1, right? And then you're going to enter the 7,500. And then this is your result. You see, you get the same thing. I believe if you do it this way, it's much student friendlier than doing it how I explained to you guys on here on the top. Now, my math lab also showed you this way, right? If you ask for assistance, right? For example, there are certain features that you can use. For example, help me solve this. Show me another example as your instructor. They're going to show you this way, guys. Okay, with this formula here, with the PV equals to FV divided by 1 plus RT. But at times, it's kind of hard for the students to actually put in the calculator. That's why, guys, I show you guys how to do it with the calculator here on the bottom with one steady flow. Okay, let's do another one. Example 3. It says, John received a $10,000 loan from his aunt to buy a car. His aunt charged him 2.5 interest. How long was the term of the loan if the interest accrued was 125? Okay, now guys, here we have to use the first formula, which is the INT equals to PVRT. Why is that? Because, hey guys, the INT is the 125 was the interest accrued, and we're looking for the time. Okay, again, we're going to use the first formula. So we're looking for T, right? What is given and what we're looking for? We're looking for time, because they're saying how long. How long means time. So the present value, right, that John received was $10,000. The interest rate was 2.5%, right? Converted to a decimal, is going to give us 0.025, and the interest accrued is 125. So let's put everything in the formula, guys, right? Plug everything in and solve for T. So here on the right side, we multiply 10,000 by 0.025, which will give us 250. Now we divide both sides by 250, and it's going to give us 0.5 or half a year, right? You can say 6 months or half a year. That's how long it would take, right, for the term of the loan to accrue $125. So the answer is half a year. Now comes compound interest. Compound interest is a different set of formulas. Okay, what's the formula for compound interest? This is a formula for compound interest. Future value equals to present value, parentheses 1 plus R divided by M, plus parentheses times MT. Okay, now it's easier, guys, to use the formula here on the right. The future value equals to PV, 1 plus I to the power of N. If you notice, the I represents the R divided by M. And the N represents the M times T. Okay? So, hey guys, for the rest of this chapter, there's 7 things that you have to list down. 7 things always. You see, there's the future value, present value, my interest rate, number of compound years per year, the time, the I, and the N. So the AV stands for future value, the future or majority value. The PV stands for principal or present value. The R stands for the interest rate per period, convert to decimal. M is the number of compounding periods per year. The T is number of years, right? The time will be in, the T with the time, it's going to be in years. The I is the interest rate period, which is R divided by M. And the N is M times T, is a total number of compounded periods. Guys, hey guys, this is a total number of payments. The N is, okay, same thing. Now, here's what the keywords are for the M, for the compounded periods. Okay, these are my keywords. So for example, if on the word problem, you see the word annually or yearly, that means M is equal to 1. If you see the words bi-yearly or semi-annually, my M will be 2. Quarterly, my M will be 4. Monthly, my M will be 12. Weekly, my M will be 52 because there's 52 weeks in a year. Daily is going to be 365 or 360. In some cases, they want you to use 360. But if it doesn't state, right, if it says daily, if it doesn't state to use 360 for days, then you use 365. Now, if it's compounded continuously, it's a different formula, which is future value equals to present value, the E to the power of RT. And now, here's what this compound interest can be used for. It says compound interest can be used to invest a certain amount of money without depositing additional money. Okay, let me show you an example. Okay, say you deposit $1,000 in an account at your bank that pays 6% interest compounded quarterly. How much money will be on your account after 5 years? And how much interest did you earn? Okay, in this case, guys, let's bring in let's bring it close to home. For example, say that you can afford. Say that somebody gave you $1,000. Okay, that way you can relate to it. Somebody gave you $1,000. They say, here, you can have $1,000, but you don't want to spend it right now, right? You want to invest it. So say you go to the bank and they'll offer you 6% interest compounded quarterly, but the money has to be there for 5 years. Okay, let's see how much money you're going to have in those 5 years, and how much interest did you earn. I like to bring everything like in life in my classes. That's why today we were covering this problem and also the annuities, future annuities, and we got examples like we came out with our own examples, like a life situation. Okay, so guys, you guys can relate to the mathematics. Okay, now, right, so this is a formula, but it's easier to use this one over here. Easier to input in the calculator. Again, there's my 7 things. So let's extract what we're looking for. Okay, what are we looking for? We're looking for the future value, right? It says here, how much money will be on your account after 5 years? 5 years is the future, so we're looking for the future value. The present value, or the money that you deposit, is $1,000. The R is the interest rate, is 6%. Convert to a decimal, will give you 0.06. The M, compounded, let's see here, compounded quarterly, so M is equal to 4. The time is 5 years, so T is 5. Now the I is going to be R divided by M. My R is 0.06 divided by 4, which will give us 0.015. And my N is M times T, 4 times 5, which will give us 20. Right, so we're going to plug in every single variable here, guys. The amount of every variable into the formula. You see, there's my present value, there's my I, 0.015, and the N is 20. So just put in the calculator, guys, and we're going to get $1,346.86. Right, because we're rounding up to a nearest penny. So this is a value that will be in the account after 5 years, will be $1,346.86. That's the answer for the first part. Okay, now for the second part, how much interest did you earn? So for that one, it's going to be the interest will be the future value minus the present value. So what we got in the future, what was $1,346.86 minus what you invested or what you deposited, which was 1,000. So here, guys, we got $346.86 in interest. You might be thinking, well, it's not that much, right? But we didn't deposit also that much. $1,000 is nothing, right? So it's not bad because we got almost like what, $350 extra. But imagine, guys, if it was 10,000, it would have been 3,460. Imagine if it was 100,000, it'll be 34,686. Okay, so let's do another example. Continuous compounding. All right, so this is now continuous. Remember, continuous is a different formula. Let's do the very same problem, but instead of being compounded quarterly, it's continuous. There's my formula. So we're still looking for the same thing, right? We're looking for the future value. The present value was the 1,000. The interest rate was a 6%, 0.06, and the time is 5. Plug everything into the formula, right? So we're gonna get, right? So make sure that you put parentheses, guys, because at times students make errors because they don't put the parentheses on the fraction. I mean on the exponent. Okay. So anyway, guys, this should be my answer. $1,349.86. Because if you notice, it's a little bit more than compounded quarterly. Okay, what does that mean? That the more times it's compounded per year, the more money you're going to get. Okay, and the least amount of compounded per year, the least money you're going to get. Here's where the banks kind of make their money. Okay, if you're going to borrow money from a bank, okay, it's going to be probably compounded. Many times, like maybe continuous or daily or weekly, because when you borrow money, right, the banks wants to get the most money out of you in interest. But then when you want to deposit money there, so they can use, right, the compounded will be less because they don't want to give you less money back in return, because the banks are there to make money, not to lose money. Okay, so that's a good way to know exactly what you're doing, right? If you're going to a bank, you can tell them, well, how many times is this compounded? And then if it's kind of let's say once a year, that means that they don't want to give you much interest in return. Okay, and most of the times that's going to be the case. Okay. Anyway, let's go to example number 6. Okay, now, how much interest did you earn? I forgot to put that. How much interest did you earn? So here, guys, right? So all we do is subtract the future value minus the present value. So it's going to be $349.86. That's how much interest you earned. And like I said, it's a little bit more than the previous example. Okay, now continue. Okay, this one here, I think I did it today in class. Okay, and I made a scenario that this can apply to anyone. Okay, so to bring it home, guys, I say something like this. Say that I want to retire in 15 years. And I want to get an annual salary of $100,000 when I retire in 15 years. I have been offered a job that guarantees an annual salary increase of 4% per year. And the starting salary is negotiable. What salary should I request in order to meet my goal? Okay, again, there's my formula. Now, there are the 7 things that we're looking for. But here, guys, what are we looking for? You see, guys, I want to earn an annual salary of $100,000 when I retire in 15, right? So this is the future, right? So eventually, we're looking for the present value, right? Because this is the future value of the $100,000. So that's my future value. My interest is 4% increase, so 4%. Convert to a decimal will be 0.04. Compounded, right? So it says compounded. Let me see here. Compounded. It doesn't say right, but here it says annually, so it's going to be 1. Right? My time is for 15. My I is R divided by M, so it'll be 0.04 divided by 1, which will give us 0.04. My N is M times T, which would be 1 times 15 is 15. So let's plug everything in the calculator. Okay, now, right? So first we do parentheses 1 plus 0.04 to the power of 15, and that's what we get. Then we divide both sides by 1.8009435506. So that's my present value, which is $55,526.45. That's how much money I need to deposit now. Okay, now, check this out. Here's another way to do it without, like I said, without leaving the calculator. Okay, so I'm going to come over here. So you're going to enter parentheses 1 plus 0.04, close parentheses to the power of 15 in your calculator. This is what you should see on the screen. 1.809435506. Then you're going to hit the inverse key. Right? Hit the inverse key. Then you're going to enter the 100,000. You see, guys, we get the same answer. And with this one, it was one steady flow of the calculator. But like I said, the book uses this formula, and so does MyMathLab. Okay? But I'm showing you guys, I think, an easier way for the students that struggle how to use a calculator. Okay? Now comes the future value of an ordinary annuity. This is a little bit different now. It's a different formula. Okay, you see, there's always 7 things, right? The future value, the payment, the interest rate, compounded, how many times compounded per year, the time, the I, and the N. Okay, now, these type of annuities can be used to accumulate funds for some time in the future. You must set regular deposits during that specific time. Okay? Examples of what these formulas can be used for. Let's say you can afford to save $1,000 every month, and you want to set up an annuity to make interest on the account. You want to deposit $1,000 at the end of every month for 20 years. How much money will you have at the end of 20 years? Okay, here's my scenario. That's a good example, right? And here's another one that I shared today in class. Okay, let's say that you are planning on sending your just born child to college when he or she turns 18. Since college tuition is constantly on the rise, you want to make sure that you have enough money in 18 years for your child to attend college. And I said this in class today, that first of all, I asked the students that who gets financial aid, right? And most of them, raise your hand up, because I believe like almost 80% of the students at EPCC, they get financial aid. So I told them, hey guys, you're here to make money, right? To finish school and then graduate with your bachelor's and then go to work at your desired job, right? So I told them, so more than likely, when your kids turn 18, right? If you plan on having kids, when they turn 18, more than likely they're not going to get financial aid because you'll be making too much money. So I told them, because you're here to make money, right? And more than likely, if you're successful after you graduate and you have a good job, then you'll be making too much money to qualify for financial aid. So then I told them that then this is a way to set up an account. Like an annuity for when your child turns 18, that he or she can attend college. Okay, so those 2 examples are the ones that I'm going to do right now. Okay, here's the first one. So you can afford to save $1,000 every month, and you want to set up an annuity to make interest on the account. There's my formula, right? Let's see what we're looking for. How much money will you have in 20 years, right? So we're looking for the future value. And how much interest will you earn? So this is like 2 parts, okay? So the first part, right, we have to find the future value. So the payments are 1,000. The R is the interest rate is 3%, which will be 0.03. My M, which is compounded at the end of every month, is going to be 12, right? At the end of every month is 12. The time is, let's say, 20 years. Okay. My I is R divided by M, which is 0.03 divided by 12, will give us 0.0025. And my N, the number of payments, will be M times T. 12 times 20 will give us 240. So again, we plug everything in. Right, so we're going to go in a steady flow in the calculator. We're going to enter the numerator first. Right, so this is your answer, guys. But I'm going to show you how to do it the other way, guys. Right, on a steady flow with the calculator. Because here, guys, you're going to stop the calculator. Right, you have to stop it and clear it and do the division and all that stuff. But let me show you how to do it in one step. How to, in one steady flow. Here we go. You can enter the numerator in your calculator just the way it is here in green. You're going to enter parentheses 1 plus 0.0025 close parentheses to the power of 240 minus 1. Then this is what you should see on your calculator on the screen. 0.8207549953. Then you're going to hit the division key, right? Because this top portion is what we just found out. So we hit the division key. And then this is what you should see on your screen. And then you're going to enter 0.0025. After you do that, it's going to give you 328.3019981. Then you're going to hit the multiplication key, and you're going to enter the 1,000. So we get 328.301.99, which runs off to $328,302. That's how much you have in the future. Okay, but let's say how much money did you earn in interest, or how much money did you actually pay? And then we subtract that from the future value. So really, guys, this is how much money came from your pocket. Right, there were 240 payments for $1,000 each, right? So it'll be 240,000. So we subtract that from the 328,302. So $88,302 was the interest that you earned on this investment, which is not bad at all. Okay. Now let's do another example here. Now again, you are planning on sending your just born child to college when she turns 18. You want to have 250,000 in an account for tuition, right? Yeah. So this is about right. Maybe like in 18 years, right? For tuition to attend college will be more exactly something like this, or a little bit more. But let's just say that you want to have 250,000 for your kids to go to college. For one child to go to college. Let's see how much money must you deposit every quarter. Is my formula right? So this is what you want in the future, right? So we're looking for the monthly payments or the quarterly payments. We plug everything in, right? The interest rate is 5%, compounded quarterly. My M is 4 because it's quarterly. My T is 18 years. My I is R divided by M. 0.05 divided by 4 gives us 0.0125. And the number of payments is 4 times 18. Will give us 72. So let's plug everything in the calculator, guys. But here, guys, I'm going to show you with a steady flow, okay, like I've been showing you. So we're going to enter the numerator in your calculator. The parentheses 1 plus 0.0125, close parentheses, to the power of 72 minus 1. So this is what you should see on the screen, 1.4459202268. Then you're going to hit the division key, right, which is right here, the division key. Then you're going to enter the 0.0125. After you do that, this is the answer. This is what you should see on your screen. 115.6736215. Then you're going to hit the inverse key. The inverse key, right? After you do that, then you're going to enter the 250,000. So the answer will be $2,161.25. Those are your monthly payments. Those are your quarterly payments. Quarterly means 3 times a year. Okay. So how much money, right? So this is the answer, right? How much money must you deposit at the end, right? So this is the money deposit at the end of every quarter. Extra information. How much money did you put into the account? Okay. How much money did you put into the account? Because at the end, right, we're going to have 250,000, but how much money actually came from your pocket? So we multiply the 72 payments times the payment. It's going to give us $155,610. This is how much money you actually put into the account. So we subtract that from the 250,000. So you made $94,390 in interest. That's how much money you got in interest, which is not bad at all. Okay. So now I'm going to do the last two examples for today's workshop. This is called the present value of an ordinary annuity. The present value, guys, is how much money you want to borrow from the bank right now. This is to purchase like expensive items, right? And again, it's the same. There's 7 things, right? The present value, the payment, the interest rate, the number of times it's compounded, the time, the I, and the N. Here's okay. Here's how they use for these formulas. The most common use of present value ordinary annuities are for purchasing an expensive item, such as a vehicle or a house, at the present time and making equal payments, including interest, for a certain amount of time in years. Okay, now the most important things, guys, that I mean for students and for people in general, they always want to buy a brand new car, right? A brand new car or a brand new house. So those are the 2 examples that I'm going to show you guys. Okay. So say you want to purchase a car. What are your monthly payments and how much will you end up paying? Okay. The second one is you want to get an idea on the process of purchasing a house. Because for purchasing a house, there are certain things that you have to know. Okay. And here they are. Here are the key factors. First of all, key factors on purchasing an expensive item, right? Whether it's a car, an expensive car, or a house. First of all, you must have a job. No job, the bank will not lend you a dime or a penny. No job, nothing. You must have a job. The second key factor, you must have very good credit. The better the credit that you have, or the higher the credit, the less interest you're going to be paying. Okay, the higher your credit score, the lower interest rate you will get, which is good. First of all, before you get something like a house, right, you must get pre-qualified for the maximum amount of a loan. For example, say that you don't get pre-qualified, and you start looking at houses, right? Maybe that'll be a waste of time, because what if you're looking at houses that are too expensive for you? Then if you don't get pre-qualified, then you'll be looking at houses, right? Then when you get pre-qualified afterwards, then maybe you got qualified for the maximum loan, right, which was a lot less than the houses you were looking for. You're looking at. Then the houses that you see, right, at your range will not seem nice, because you got used to looking at houses that were real expensive. That's why the first thing, guys, that you do when you buy a house is first you get pre-qualified. This way you will not be wasting your time. Okay. Anyway, those are the 3 things, the 3 key factors that you must take into consideration. Now, let's do example number 9. You buy a new car that costs $26,750. What are the monthly payments if the interest rate is 4.2% and the loan is for 5 years? And how much interest did you pay? In other words, how much did you end up paying for the car? In reality. Okay, here we go. So this is a different formula, right? So this is the amount that you got qualified for at the bank, right? Because that's how much the car costs. So we're looking for the monthly payments. So that's the money that you borrow from the bank. That's why it's called present value, right? The present value means that you borrow the money right now at the present time. The interest rate is 4.2%, which will give us 0.042. The loan, the M, because the M is always going to be 12 for a house, or for a car. It's going to be 12 because you make monthly payments, so it's going to be 12. The time is 5 years. Now, I will be R divided by M, will be 0.042 divided by 12, will give you 0.0035. My n is m times t. M times t was 12 times 5 will give you, what, 60. So let's plug everything in. Again, let's do it in 1/34 of the calculator. So we start with the numerator. We're going to enter this in the calculator. 1 minus parentheses 1 plus 0.035 close parentheses to the power of negative 60. Once you do that, you're going to get something like 0.1891185,031. Then we're going to hit the division key. Right? When you do that, this is what you should see on your screen, on your calculator. Then you're going to enter 0.00335. After you do that, this is what you should see on your calculator. 54.03385,802. Now you're going to hit the inverse key. Okay? Once you do that, then you're going to enter the 26,750. So the payments will be $495.06. That's how much your monthly payments will be. Okay? Okay, now that's the answer for the first part. What are the monthly payments, which is $495.06. How much interest did you pay? Okay, how do we do that? We get the number of payments, right, which were 60 times the payment, which was $495. That gives us $29,703.60. That's how much you end up paying for the car. Okay, now how much interest did you earn? Did you pay? So we subtract the original price of the car, or the money that you borrowed from the bank, from the total, which was $29,703.60, right? So you paid almost $3,000 in interest, right? You paid $2,152.60 in interest. Okay, now at times, guys, that interest can be cut down. If you don't want to pay too much interest, it can be cut down. How can you cut it down? Is that you give extra payments to the principal every month, or whenever you can, just do that. That way you can knock down some of the interest that you paid. So you always pay extra. That way you don't have to end up paying as much as here as a $2,153. Okay. Now this is the last problem, guys. This is about a house. Okay. And I like to share this with my students because this way, I mean, most of the students are kind of young, right? Like right out of high school and stuff like that. And everybody dreams of having a brand new house, like a real nice house, or like a real nice car. That's why I chose these two examples on these particular types of annuities. Okay, so here's my scenario. You want to purchase a house that costs $325,000 with a 30-year fixed rate at 3.9%. What are your monthly payments and how much interest did you end up paying? Okay, so again, same formula as before for the present value of an ordinary annuity formula, right? So we're looking for the payment. So this is the money that you borrowed from the bank, the $325,000. The interest rate is 3.9%. The M is the number of compounded, right? So it's going to be monthly. Like I said earlier, for expensive items like a car or a house, it's most of the times the M is 12 because you do monthly payments. The time is 30 because most of the homes, when you buy a home, it's going to be for 30 years or for 15 years. If you do 15, guys, it'll be much you end up paying less interest at the end. But maybe you cannot afford the payment because it's going to be a higher payment. Okay, but anyway, guys, let's finish this scenario here. So my I is going to be R divided by M. The 0.039 divided by 12 will give us 0.0325. My N will be N times T, will be my 12 times 30, which will give us 360. Okay, so let's plug everything in. And now, again, we're going to do 1/34 of the calculator, guys, so you guys can eliminate some of the mistakes. So we're going to enter the numerator into the calculator, the 1 minus 1 plus 0.00325 close parentheses to the power of negative 360. After you input that, this is what you should see on the screen. 0.6890436901. Then you're going to hit the division key. Right? Then you're going to enter the 0.00325. And this is a result. You should see 212.0134431 on the screen. Then you're going to hit the inverse key because this takes everything that's on the right of the payment. All this calculation is 212.0134431. Now you're going to hit the inverse key. Right? And then you're going to enter the 325,000. So your monthly payments are $1,532.92. That's how much are your monthly payments. Okay, now that's the answer for the first part. But how much did you end up paying for the house? Okay, you guys are going to be shocked how much more you end up paying. So how much money did you end up paying, right? For paying, so there were 360 payments. So you multiply 360 times the payment times the $1,532.92. So you end up paying $551,851.20. A lot of money, right? You end up paying like, I'm not gonna say almost half of it, right? Almost like double, no, but you're gonna end up paying like what? Well, let's find out. So you end up paying a little bit over a quarter of $250,000, which is $226,851.20. That's a lot of money, right, to pay extra in those 30 years. Now, how can you avoid paying this much interest? Is you always give extra money. You give $100 or $200 or whatever it is of the interest, and this way you can pay it off quicker, and also you can pay less interest. For example, when my wife and I got a house on the Northeast, right? She actually got the house, and then but we use mathematics to pay it off in 10 years. Okay, that's how you can use math. All I did was give extra payments and extra money into the principal. That way, it goes straight to the principal and lower the interest. At the end, we end up paying less interest than what we should have paid if we would have gone with just the minimum payment. So the smart way, guys, is to always pay extra every time. This way, you'll pay less interest. Okay? I believe this is it for this PowerPoint. If you have any questions, let me know. If not, well, let's go back to the host so they can let you know what's going to be going on next week.
Okay, thank you very much, Mr. Isasi, for that wonderful presentation. I hope all of you learned something. At least you learned how much you're going to be paying for a brand new house and how to save money by paying a little extra. I'd like to invite all of you later on today for the Tejano Virtual Events presentation at 1 p.m. And we're going to be having the STEM Student Resource Page presentation. Next week, we'll be covering in Happy Math Hour XM2 reviews. And also the Student Success will be covering the Writing Center and Succeed with CSD. So if there's any questions, please address them now, and we'll stay here for a little bit longer. Thank you.